Hi there, you're in the lab with your mate JJ. Today is Learning the Art of Electronics Day. Today we're learning the art of electronics. My silly job title for today is Surge Sage. Today I'm the Surge Sage. And of course in our Learning the Art of Electronics videos, we're working through the book with the same name. Today we're going to be measuring the voltage of our multimeter when it's in resistance measurement mode. And we're going to do we're going to use one multimeter to do the measurement and another multimeter to measure the measurer. And then what we'll do is once we've got a full set of readings, we'll flip it around and we'll make the one that was measuring the resistance test the voltage, and the one that was testing the voltage measure the resistance. So we'll collect a table of results and then we'll write them up. And then because we do the practical first in these videos, and then once that's done, we'll head over and we'll go through our notes. There will be a little bit of revision from last week, if you were watching last week. And then once that's done, we'll be finished. So what we're going to do is pop over to the bench and get our measurements. Then we'll jump over to the computer and write them all in. All right. Well, here we are on the bench. Not sure what that bit of wire is doing. I don't know. We're going to need the notebook. So let's prepare that. About right. Now, I've got my pencil here. Very good. What's the date today? It's the 11th of the 11th, 2025. And what are we working on today? Let's have a look in here. Okay, so we're up to 1L.2.3. 1L.2.3. So that's learning the art of electronics. 1L.2.3. All right, and we're going to be running through our variable resistor here, and we'll do all of the ones. So we'll do, let's say, R, and then we'll have 1, 10, 100, and then 1K, and then 10K, 100K, and then 1 meg. And we're going to measure the voltage so let's get this all wired up. So we're going to put the resistor into the EV block, and we're going to put that in resistance mode. So that will be up here, and we don't want that. We don't want that. We don't want that. That's what we want. All right. So there's our EV blog meter measuring resistance, and then we're going to use this guy to measure the voltage. So we'll put that in there, and this one in here. All right. So we're going to put this on millivolts range. Okay. So it seems to be happy in millivolts range. Very good. All right. So let's put him in 1 ohm. Okay. So that 1 ohm, I found that it's really easy to bump these switches. They're very easy to accidentally enable. So yeah, I'm not sure what's happened there. This is showing mega ohms. Why is it showing mega ohms? I don't know. It seemed to be working right before. Oh, there we go. It's working now. All right. And we'll put in one ohm, and we're reading 5.5 ohms. Okay, so we're reading 5.5 ohms. Okay, so we're not going to be recording the resistance. We're just going to be recording the voltage. So it's 0.7, and then we're going to bump up the resistance. There seems to be about 5 ohms worth of resistance on the cables. Anyway, we're at 10, and this is 2.1 millivolts. And then let's bump it up to 100, and we're reading 15.8 millivolts. And then we'll bump it up to 1K, and we're reading 81.5, and then we'll bump it up to 10K, and we're now reading 140.5. Then we're going to bump it up to 100K. That's about the same, 139.3. And finally, let's do 1 meg and see how we go there. And we're reading 93.4. 93.4. Isn't that interesting? All right, now what we're going to do is we're going to switch everything around. So we're going to put this in millivolts range, and we're going to put this in ohms, and we're just going to take out these. And we're basically just switching the roles. So now we'll take him. Oh, look at that! I had that 1 on the whole time. That shouldn't matter much. Put him back on down there. Now, this is the fluke, and we're going to put 1 in. Oh, isn't that fascinating? All right, so it's reading 278.6. 278.6. And then we'll pop in the 10 ohm, and that's 278.6 still. 278.6. And then we'll bump it up to 100. Still 278.6. Okay, we'll bump it up to 1K. 278.6. And what about 10K? 10K? 448.5. 448.5. Fascinating. And then this is 527. 527.7. And same again, 527.7. Wow, that's really quite amazing, isn't it? Anyway, let's take this over to the bench. I'll write up our results and then we can talk about them. Actually, before we take the results over to the computer, I thought I'd give it another run. And I'm going to record the resistance values as well as the millivolt values. So, but I'll do it in time lapse with you. So let's do this together quickly.
All right. Well, I don't know what to tell you. I'm so glad that I redid these numbers because this whole block of numbers where it was 278, 278, 278, 278, I did not get those readings this time around. So I really don't know what I did wrong when I took this block of readings, but they are all well off. And that was surprising to see that. Did you notice what I did? Did I do something wrong? I'm not sure. Anyway, having redone the numbers, this is far more satisfactory. So these are the numbers that I'll write up for our notes. So I'll pop over to the computer now and we'll write up the notes.
Here we are on the computer. So just going to jump over to the show wiki. That's the ITL wiki over here on inthelabwithjj.com/wiki. And we're going to be working through learning the art of electronics. And we're into the second edition of the book. And loading. There we go. So we're up to lab for DC circuits. So I'll open that over here. Now we'll do a little bit of revision. This is reviewing our notes that we took last week, and then we'll get down to the results of our experiment. So this lab is to get you used to using with the breadboard and the multimeters. So it's just getting that handle on the equipment. They say here that they don't expect us to find Ohm's law surprising. So it's pretty basic stuff to begin with. They make a note here that voltages are measured between points in a circuit, whereas currents are measured through a point in a circuit. And as they say, this means you usually have to break or interrupt the circuit in order to measure current. Analog meters are known as VOM, which is short for volt ohm milliammeter. And the digital meters are known as DVM, short for digital voltmeter. You will also see DMM for digital multimeter. To measure current, a DVM runs the input current through a small valued resistor and measures the voltage drop across that resistor. The small voltage that the DVM drops when measuring current is called the burden voltage. This is what we had a look at last week when we did this experiment to try our DVM's current measurement burden. So we did this experiment twice. In the first instance, we measured milliamps, and in the second instance, we measured microamps. Yeah, it was pretty interesting. So you can see that the burden voltage actually changed depending on which sort of current measurement we were taking. And when we took a higher fidelity current measurement, the burden voltage actually went up quite a lot. So that was kind of interesting. And of course, up here, once you got through to the 1 meg range, it just all zeroed out. Whereas with the microamps, you had the opposite problem with the overload for the low value resistor. Anyway, as they say down here, if you're measuring circuits with components in circuit, you should be skeptical of your results. And they say here it's best to disconnect at least one end of the resistor before taking a measurement. So if you can take the part out of the circuit, that's usually best if you're going to be measuring it. And here we are today. This is what we've just done over on the bench. So an experiment, try your DVM's resistance measurement. In this experiment, we use one DVM to measure resistance while the other DVM measures the voltage drop during the resistance measurement. Ideally, the voltage will never exceed half a volt so as to avoid powering diodes and transistors and such. The first set of readings are from when we used the EV blog meter to measure resistance, and the second set of readings is from when we used the fluke meter to measure resistance. And you'll see in the end that the results are actually quite similar. So when we had the input set at 1 ohm, both of the meters registered 4.2 and 4.5, so around 4, which tells me there was probably about 3 ohms or so of resistance in the cables and the connectors and this sort of thing. And that's kind of constantly there as well. When we did 10 ohms, there was the 3.2 ohms and the 3.6 ohms in the cables again. And you can see that the voltage drop increased. So the amount of voltage that was applied increased, and indeed increase, and then decrease and decrease. So it's not super, like, I don't know why it goes high and then it goes low. I don't know. If you understand the rhyme and reason behind this, I'd be very happy to hear from you. And similarly, those results are very similar. But this one sort of gets up to about 240 and then it stays around there, doesn't it? Whereas this one falls all the way back down to 93. Anyway, that's everything. That's the end of the video. I think what I'm going to do, though, if just quickly together, we'll jump back over to the bench. I'm going to take a third set of measurements and just see see if this is reproducible, because I'm a little bit suspect. So for the sake of completeness, let's pop over to the bench and do a third set of readings.
All right. Well, here we are on the bench, and we're going to just prepare for our next set of measurements. So this is LAOE 1L.2.3 on the 11th of the 11th, 2025. And we're going to do R and then EEV log and then fluke. And we're going to put R here and MV here and R here and MV here. And then we're going to have 1, 10, 100, 1K, 10K, 100K, and 1 meg. All right. So let's see what's measuring what. All right. Well, all right, now I'm just going to do this in time lapse with you. All right, so there's our third set of measurements. I'm going to take them over to the computer and just compare them with the previous lot.
All right, well, here we are, and I'm just looking at these results as compared with these results, our third lot, and they are very similar. Everything, in fact, everything matched perfectly, really, very perfectly. Most of the readings I got were dead set exactly the same. Otherwise, they varied by like 0.1, very minor deviations. So we still see the same thing where this goes high and then comes low. This also goes high and comes low. I'm surprised about the fluke reading 900.9 meg for 1 meg. The EV blog meter seems to perform closer. I assume the true resistance is closer to 1 meg, so it's weird to see this being off by like 100K. That's sort of surprising, but it was consistent. It did the same thing in both sets of measurements. Anyway, that's it for today. So I'll throw over the farewell cam. We'll wrap up.
And that's a wrap. So, what can I tell you? We did our experiment. We tested the voltage that was applied to measure the resistance. We found that the two different meters had slightly different characteristics. They did seem to sort of go up in voltage and then come down in voltage as we went through the range of resistors. So I don't think that there's a hard rule about whether it goes up or down. It seems to be, I don't know why it sort of goes up in the middle and falls down around the edges. I don't know. But now we know how it behaves. We did a whole extra verification step. So we repeated our results. So that was good. So I think that's everything. That's the end of this video. I hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe.